All right, guys, so this video is about the last big shape we'll be studying for polar coordinates, okay? So you will need decimals again, and you will need to go to the wrench, and you will need to change it to polar, okay? All right, so the first thing I want you guys to type in is r equals 6, and then I want you guys to type in sine, and then I want you to type in theta. So go to ABC, go to theta, okay. So you might notice that you just get a circle, okay? But you also should notice that it still has symmetry to the y-axis. So it is sine, that symmetry still holds because this point right here and this point right here have the same sine value. So that's something that's consistent. Okay, so I want you guys to put your cursor right in front of theta, and I want you to change. So right now that's like a 1, right? Okay, so if you have a 1, it's like a circle. Okay, I want you guys to put a 2 in front of it, okay? So this shape, believe it or not, is called the rose. I mean, to me, it looks more like just a regular flower, but they called it a rose. And these are called petals. Okay, I'm not kidding. This is what they're really called. And this, of course, you see has 4 petals. Okay, the symmetry still holds. Okay, and if you notice this 6 right here, okay, that's the length of each petal. So even though here, let me make sure to see if you can. Let's see. It's not very dark. But let me see if my computer is, for some reason it's just kind of hard to see that. But anyway, this right here is 6. This right here is 6. Okay, all these petal lengths are 6, which is of course because of the number in the front. And then the petals right here depend on the number you put in the front. So like if I kept the number 2 but changed it to a 4, it would just make the petals shorter. Okay. All right, I like the 6 though better. Okay, so then I want you guys, we're gonna establish a pattern, of course, but I want you guys to just try a few out. So just do as many as you need to until you feel like you're pretty happy with your pattern. So go take the 2, change it to a 3. Okay, not the coolest looking shape, but it is what it is. Kind of looks like a little face, right? Okay, and then change it to a 4. Okay, that's prettier. Okay, then change it to a 5. All right, then change it to a 6. And I just need you to do this until you can answer the questions on the sheet. Okay, so you should be able to answer the question, what value of n would make a rose with 11 petals? Okay, and if you're not sure, then try something, count the number of petals and see if you got it right. Okay, and same thing with what value of n would make a rose with 12 petals. Okay, so just try that out. I'm sure you guys have figured this pattern out. Okay, you should know that the symmetry is always y-axis no matter what. And then just say, how do you make a circle? So that's what we did first. So try to remember how we would turn this beautiful little rose into a circle. Okay, so that's all question number 1. Okay. All right, question number 2 is, I just want you guys to go back, take that off, and change the word sine to cosine. Okay, so as you can imagine, when the number in front of theta is 1, you get a circle again, but the circle is going to look different for cosine because cosine has different symmetry. So this has x-axis symmetry because the cosine of pi over 6 and 11 pi over 6 are the same and all that stuff. Okay, let me just make sure. No, okay. Okay, so then I want you guys to do the same thing. I want you to put a 2 in here. Okay, and that does look different, just so you guys are clear. These are not exactly the same, although you might not remember. Okay, hold on. I'm gonna do both at the same time. Okay, so the blue one is the sine one, and the red one is the cosine one. So what they have in common is they both have 4 petals, right? But they don't have the petals in the same spot. Okay, and of course this looks beautiful. You know, that polar art project I have hanging all over my room that we're obviously not going to get to do this year, unfortunately. This is how kids got that. They would like color in these little spaces and graph a bunch on the same thing, and it would just be pretty. The rose was a pretty common one because it's just so pretty. Okay, so this is the cosine one, and then the same thing. I just want you to try if you know that's the 3rd, that's the 4th, that's the 5th, okay? And of course you can do really high numbers, but the calculator does have issues with that. So that's if you put 100 in front of that. So you could try to go high, you know, but at some point, you know, it's just gonna be like, really, you know, I can't graph that many. Okay, and it does look like a big ball in here. It's not, you know, if you scroll, Desmos is so cool. Whoa, that looks like crazy. But you can keep scrolling and scrolling, and eventually you can see, look, oh, cool. Okay, so anyway, just have fun with it. You know, one of the nice things about this unit is it's just fun. So have fun. Let's see, go back. Sorry, I'm getting a little off task. Okay, so you should be able to answer the question number 2 now. What is the pattern? You know, what happens if n is even and what happens if n is odd? If you're still not sure, just, you know, come up with a theory and then try it out, okay? And so I want you guys to answer those questions on your own. I want to give you exactly the answer, okay? And then there's one thing I really need to talk to you guys about. It's just really important. Okay, so there's some roses. Let me type it when it's a little bit simpler. Okay, we talked about symmetry, right? So we talked about x-axis symmetry and y-axis symmetry. There's some roses that have both. So if I put this rose up on the screen, you know, you wouldn't be able to just use symmetry to figure out if it's sine or cosine or not. And it's not like a sine and cosine graph where you can do both. Like this is not both sine and cosine, it's just one or the other, okay? So this is the feature that you will use to determine, okay? Let me show you. Oh, I love doing this. Okay, so if you have a graph, okay, we all know that if you have a graph like this, r equals, let's see, what did we do, 6, and we have cosine, and then we have 2 theta, okay? We all know that if you plug in theta equals 0, okay, that if you multiply 0 by 2, it's still 0, and we all know that the cosine of 0 is 1. So if I plug 0 into here, I would get 6 times 1, which means at 0, this petal goes out to 6. And the thing is that cosine of 0 is always 1, so a cosine always has a petal here. So cosine always has a petal here. Has a petal here, okay? And sine never has a petal there because the sine of 0 is 0. So it's impossible for a sine graph to have a petal on the x-axis, okay? So this is how you figure this out. So this is not a sine rose, this is a cosine rose, okay? So let's go back and try this out a little bit. Okay, so if I typed in, let's see, cosine 3 versus sine 3. Okay, so here's your two problems, okay? They both have 3 petals, okay? And if you looked at just this one, you'd be like, there's no way that's cosine because there's no petal right here. So this is definitely sine, and it has the sine symmetry. Okay, and then you type in this one, you're like, oh, this has to be cosine because there's that cool petal and it has symmetry to the x-axis, okay? It's the tricky ones is when it has both. So remember, if I do this, this has both symmetries, x symmetry and y symmetry. So which one is this, cosine or not cosine, okay? Sorry. And hopefully, my cat was playing with a little toy. Oh gosh, sorry. All right, so hopefully you figure out that this is not cosine because there's no petal right here. So this is a sine rose, okay? All right, we can always talk more about that in Zoom if you guys have questions. Okay, so this next part, okay, I have to use my graphing calculator. And unfortunately, I know that most of you don't have your graphing calculator, so you're really just gonna have to watch this, okay? I'm gonna show you something cool. Okay, so if you have a graphing calculator, you do have to set it up by, hold on, I'm going to try to figure out how to best do this. I think I have to take my, hold on, sorry, take my phone off this and just go hold it over it. Okay, so if you wanted to do this with me, sorry guys, you would have to go to mode right here, mode. And we are now in polar. So see right here how it says polar? Okay, but I know you guys don't need to do this even if you have a graphing calculator. Okay, so what I did is I set the function so that, see it has a little ball right here? So it actually shows the rows graphing. So the one fault of Desmos is that it doesn't show you the path. Okay, this is really important. So this is 8 cosine 2 theta. So hopefully you guys know that 8 is the petal length and the 2 determines the number of petals. So if there's a 2 in front, okay, I want you to think in your head how many petals it should have. Okay, and then I'm going to put graph, and you're going to see if you're right. Okay, and then see how I can see it plotting. So cool. Okay, so hopefully you thought there was 4 petals, and there are 4 petals. So hopefully this is what you thought. Okay, and because there's a petal right there, this is a cosine rose. Okay, all right, now this next thing is really important. Okay, so if you go over to here, okay, sorry, and you type in a 3 instead, you might think to yourself, oh, I got this. I know this has 3 petals, but I want you to watch something. Okay. So there are your 3 petals you thought, but watch the ball. It keeps going and goes around a whole nother time. So technically, we don't call this a 3-petaled rose. We call it a 6-petaled rose, because even though you only see 3, it actually goes around and makes 6. It just happens that 3 of them land right on top of each other. Okay, so let's do that again. Okay, if I type in, and it works with sign too, just so you know. If I type in 5, you might think to yourself, well, that has 5 petals. We just went over this in Desmos. And it's true, sorry, that you see 5 petals. Okay, but how many petals are there actually? Okay, so there are the 5 petals you see, but watch the ball. It goes back over every single petal again. Okay, I know, this is so cool, right? Okay, so here is the thing. Okay, so even though, hold on. Sorry, I know this is a clunky video. Okay. So I want to show you something. Okay, so let's do like 7. Okay, and then okay, sorry, thanks for your patience. Okay, so if I gave you a problem like this, so on the back of your ditto, there's like a little chart, and it says, please fill out this chart, okay? So I gave you an equation, okay, so this one would have been R equals 6 sine 7 theta, okay? All right, and then the questions say number of petals. Okay, what I want you guys to say for this is I don't want you to say that it has 7 petals. I want you to say it has 14 petals, okay? But you only see 7 petals, okay? All right, and then the length of each petal length is 6. Sorry I'm writing so messy. I don't want my arm to be in the way and then it makes me write really messy, okay? So again, the 7... so basically, here, I know what it'll do. Clear, can I erase this? Oh gosh, that is not what I meant to do. Try to erase. Okay, so if you have a rose, okay, so I'll try to write neat this time. R equals A sine n theta. Okay, so if you have a rose, okay, the nice thing is there are always 2 n petals, no matter what. There's always 2 n petals, okay? Now, if it's odd, you only see n of them, and if it's even, you see all of them, okay? All right, so let's go over that again. If there's the number in front of theta, I mean, there's always twice as many petals as that, okay? If it's odd, you only see n of them. So like this one, this is a 7, you only see 7 of them, okay? If it's odd, you only see the number that the number is. If it's even, you see twice as many as that, okay? All right, so that's what I want you guys to go over, and just email me if you have any questions. Hopefully that was clear. Okay, bye you guys.